If you visit the system requirements page for PixInsight, they tell you very clearly that they recommend using Linux to run PixInsight, which approximately no one does ever. Well, I'm exaggerating, but basically I think most people are running either Windows on PC or macOS on Mac. If you're lucky, you're having one of the M1, 2, 3, 4, whatever is the current version of the M processor series Mac, and then you're all set. If you're unlucky, you're still on one of the older Macs with Intel processors, in which case this video might also be for you. I don't know much about running Linux on a Mac, but I wanted to see whether I could download free RAM by using Linux on my PC instead of Windows, and whether I would get a perceptible PixInsight performance increase under Linux. Now, I've tried this experiment on a laptop years and years ago, and the answer was yes. But I want to do an update here because these days I'm using a PC with an AMD GPU. And if you don't know, if you have an AMD GPU and you're running Windows, well, you don't have access to hardware acceleration for AI processes like Blur Exterminator, Noise Exterminator, Starnet, Star Exterminator, etc. Right? Which means that your AI processes take forever to run. But if you use Linux, well, AMD has proper hardware GPU support on Linux. They're starting to trickle it down to Windows, so it's probably only a matter of time before we get that to Windows. So I would get the additional advantage of having much faster AI processes, but I also want to see with PixInsight whether I can get better performance in normal processes like running scripts, like db extract, for instance, that lets me easily like split a one-shot color image taken with a narrowband dual band filter into H-alpha oxygen 3 or sulfur 2 oxygen 3, and then I can play with the images and get a full Hubble palette image, that kind of stuff. Maybe on multi-scale stretching that PixInsight added recently, that kind of stuff. Will I get a noticeable performance difference? Yes or no? Let's try it. So first, let me tell you a bit about my setup and the rules that I did to perform this analysis between Windows and Linux. So first things first, I used the latest version, like all of the updates on Windows. And on Windows, I used the latest version of PixInsight, which was released on May 22nd, this year, 2026. So it's we're on the 24th today, so definitely the most recent, 1.9.4.02 or something like that. And I used the same version on Linux. Now, Linux is just like a kernel, an operating system kernel, and there's tons of services and desktop environments and interfaces built on top. There's a lot of choice. It's very confusing for end users, but these days I saw that the most popular Linux distribution, according to the Steam hardware survey, was CachyOS. Okay, so I went with CachyOS. They have a very good wiki about how to install Linux on my machine. I made sure to have 2 NVMe mzn.to drives, so super fast, so that I could have one drive running Windows, one drive running Linux, and I can dual boot between the two without having to do any partitioning, basically splitting like a disk into two, one for Linux, one for Windows. That's not going to work very well because Windows is very impolite when it comes to having other OSs on its same drive. So there you go. I ended up with CachyOS. As of May 2026, it is the most up-to-date version of CachyOS. I installed PixInsight on CachyOS, and then I ran some instructions that someone put on a PixInsight forum to install the latest version of the hardware acceleration for PixInsight. It's called AMD ROCm, and it is version 7.2.3, I believe. So here we go. We are on this CachyOS versus Windows 11 PixInsight benchmark analysis. Before we go further, like I'm on the Linux distribution right now. I'm on CachyOS, and you know it's very close once you've got it installed to Linux. If I want to run PixInsight, I have it here. I just click on it. PixInsight runs. It runs beautifully. I don't have really any issues, and I also have like SETI Astro Suite running, and I have Cyril running as well. None of those seem to have any issues, so this is pretty nice, right? And I'm finding that I'm spending most of my time running on CachyOS rather than Windows because there's a lot of small annoying changes in Windows. Like most recently, it replaced Chrome with Edge as the default browser without telling me anything, which annoyed me. So there we go. Anyway, so we're going CashOS versus Windows 11. Now the hardware itself. So I mentioned I'm using an AMD GPU, so graphical processing unit, graphics card basically. And this is the top end of AMD, which is the RX 9070 XT. The reason I chose this is that it rivals the performance of the NVIDIA RTX 5070 Ti graphics card. It's less good at ray tracing, path tracing for games. I don't care about that. It's better in terms of pure what we call rasterization, like compute grunt for graphics type of deal. So that's what I got, and it's cheaper than the 5070 Ti, much cheaper actually in Japan. It's possible that my results may be less impressive if I had 64 gigs or 128 gigs of RAM, but I'm not made of gold or diamonds. So yeah, only 32 gigs of RAM. Now obviously, in terms of the testing specifications, I'm using the same hardware because I'm running on the same PC. The only difference is the drive that the OS is installed on, and therefore the drive that PixInsight is using. But I actually normalized that by installing Windows and Linux twice each to swap the drives around. So, and I saw exactly the same type of results. So that's fine. It shouldn't make any difference. Then we have the methodology. Each test, and you'll see the range of tests that I used. I used 3 consecutive runs per test. And some processes, they obviously have some kind of initialization phase that they perform the first time they're run after PixInsight was launched. And so if I saw a big difference between the first test and the second and third, I would dismiss the first test, run a 4th test, and then just use like test number 2, 3, 4, both on Linux and on Windows. And then the metrics themselves, I'll show what I used in a moment, but it's a comparison of execution times in seconds, or because I've been using also the PixInsight benchmark, the indices, like no unit to compare between the two. Okay, so the first test I did is I noticed that in PixInsight these days, when you install it, it asks you to run a test called performance-x. You can type that, run it, and it will do a lot of computations there. And it does computations that seem to be relevant for PixInsight in general, like color space conversion, get lightness, get intensity, histogram generation, histogram transformation, PSR fit, convolution, like all of this stuff that is exactly, what a lot of operations under PixInsight do. So I thought like, hey, this can be a really great benchmark, like a synthetic type of benchmark to see what I can expect between Windows and Linux. So I ran performance-x to really see like how much time it would take under Linux versus under Windows there. And the results are in here. And I was a bit worried because, on Linux, I got like the average time was 38.17 seconds over 3 runs, although you can see that the run that I did in preparation for this video was actually much faster, by 3 seconds, whatever. Windows 11, 135.1 seconds. So I was like, what the heck is going on there? Like, this is weird. And so I think Performance-X is probably not the best to verify that, but it was very interesting to see how much shorter it took in terms of time on CashOS than it did on Windows. I have no idea why. If you know, let me know down on the comments. No. Then we have the benchmark itself. So PixInsight has a benchmark. If you go under PixInsight, I believe, script benchmarks, you have the PixInsight benchmark here that you can run and then upload your results online if you want. So you would just like enter, click run benchmark, and then you click on submit as soon as you have 3 benchmarks. So you need to run it 3 times, then click on submit, and that will put an entry under the PixInsight benchmark database, I highly suggest that after or while watching this video, you actually do that so that you gather more data for people to look at the benchmark results for PixInsight to help decide what hardware they should be using. But anyway, here we are with the benchmark, and the results are very interesting still, because you can see that we see a very interesting. Let's start by the total performance. For Windows, we get a score of 26,700, and for CachyOS, 32,700. That is a very big difference. But when we look at the individual components, we have a CPU score, which is 29,000, almost 30,000 on Linux, and almost a bit more than 29,000 on Windows. So there's much less difference on CPU, which made me think, okay, CPU is slightly faster on CachyOS. That's fine, but it means that for a lot of CPU-intensive processes, I shouldn't really have any big difference, right? Which is kind of belied by this, but whatever. And the big difference, what made this difference of score overall, was the swap performance on this synthetic benchmark. It's 14,000 on Windows, and it's like 55,000 on Linux, and that's insane. I don't understand why there's such a big difference. And again, I installed Windows and Linux like in quick succession on the same drive as well, and saw the same thing. So it's not about the NVMe drive that the OS is installed on. It's really about the handling of swap. So I was very interested in that. I did get better results on Windows if after uninstalling Linux, I had the swap pointed to the second drive. And I think it took the score to something like 20-something thousand on Windows. So a bit better, but still nowhere close CachyOS. Very interesting stuff to me. But it's just a benchmark. It doesn't mean anything. What about real-life scenarios? The real-life scenario first, automatic background extraction. Automatic background extraction with subtracting the resulted background is something like, it's basic, right? It's something that you will use if you're not using Raxpert, for instance, and it's repeatable on the same image. Oh yeah, and by the way, what image have I used for that? Just to be clear, I'm using this Rosette Nebula image. Yes, I want to exit the benchmark. It's an image I took a long time ago with an IMX571 sensor camera from TopeTech, I believe. And it has been drizzled ×2, so it's a very high resolution here. I think it's over 100 megapixels. So any process will take time, which should let us see like more margin between the processes. So I use the same image, of course, in Windows and in Linux. Loaded from disk directly. ABE, I'm like, oh, there's no difference. Look, even like Windows is slightly faster, right? So yeah, maybe this whole video is about nothing. Maybe it's just the benchmarks that say something, but in practice, I won't see any difference, and I cannot recommend installing Linux because it is a whole new operating system, and it's not for the faint of heart. Like really, it's not for the faint of heart. Okay, so the next thing I wanted to check was dbExtract. So dbExtract, it's one of those utilities that I use a lot if I'm doing like one-shot color narrowband, which a lot of us are doing. So that's when you're using an HA03 or S203, for instance, filter on a color, one-shot color camera, and then you want to split the channels into hydrogen alpha and oxygen 3. You can do it manually, but it's a pain. So dbExtract is a script that automates that, and it's very convenient. And here we see that this time CachyOS, or Linux in general, is faster than Windows 11 by around 2.5 seconds, right? So it's actually 18% faster overall, so that's a significant improvement. It only saves me 2.5 seconds per execution of dbExtract, but then I think about something that uses a lot of operations in a row, and that's like stacking. We'll look at stacking a bit later, like the differences between stacking on Linux versus on Windows. Let's keep going. dbEyer. So dbEyer, I use dbEyer on this color image. It makes no sense, right? But the fact is dbEyer doesn't care. It just does exactly the same operation, whether you have a Bayered image or a color image. It just takes all of it does a pixel math operation basically. So of course I'm using all of the same parameters all the time. And again, we see CachyOS or Linux being considerably faster by 2.5 seconds again. This time it's 23% overall than Windows 11. Okay, one time is coincidence, one time is luck, two times or twice is skill. It becomes skill, right? What about three times? Multi-adaptive stretch. So that's the new process in PixInsight, which these days I recommend, I use personally over anything else. I think it's a very good process that they added, really, really good. And we see the same thing again, a 2.45 advantage for CachyOS, for Linux, over Windows. Now, by the way, I keep saying CachyOS, but I also did similar tests with another Linux distribution called Fedora, and I saw very similar stuff. So if you want to go into the comments and say, like, yeah, but CachyOS is super optimized, etc., well, Fedora is basically the same. Just FYI. Anyway, yeah, again, 18% faster on Linux. That stacks up, right? And so those core operations, that are the operations that I use very often and that take more than 1 second, basically. They saved a total of 8 seconds. 8 seconds, come on. But it's 15% overall advantage, which is dragged down by ABE, right? But it's still something that I thought was interesting to have a look at, right? It's significant to know that for free, if you install Linux, and I would only recommend that on a PC if you have a second drive that you can install Linux on, and you can always switch back to Windows whenever you like, because otherwise, yeah, it is involved, right? Installation is super easy, but the initial configuration, especially CachyOS, is not the friendliest. I think Nobara would be my recommendation for something much friendlier, or Linux Mint, actually. Sorry, let me step back. If you're going to do that, use Linux Mint, or potentially Kubuntu. And those, like Kubuntu is actually the one together with Ubuntu recommended by PixInsight or supported by PixInsight. CachyOS isn't, FYI. Anyway, then I tried Graxpert. Graxpert, it's a process in PixInsight, but the fact is it uses the Graxpert software underneath. And I thought, like, okay, Graxpert is still a background removal tool that I use all of the time. It can be hardware accelerated, but the fact is on both Windows and Linux, for my GPU, as far as I can tell, it's running on CPU. It's not GPU accelerated. And yet, even though it's not PixInsight, Graxpert also saw a big difference. Is it like, is Linux in general more efficient than Windows? I don't get it. But yeah, Graxpert also has a significant performance advantage over Windows Graxpert by 29%, which is like 3.5 seconds here. Then we come to the full AI tool suite that I always use, which is Blur Exterminator, Noise Exterminator, and Star Exterminator. So this is not so much, well, it is in a way Linux versus Windows if you're using an AMD GPU. At least I believe RDNA3 and RDNA4 series of GPUs will work with hardware acceleration under Linux. And it's not currently possible under Windows, although I expect this to change in the next year or so. I don't know, we'll see for sure soon. But effectively, it makes Blur Exterminator, Noise Exterminator, and Star Exterminator roughly 11 to 12 times faster than on Windows for AMD GPUs. So for this reason alone, if you're using a recent AMD GPU, like 7000 or 9000 series, I believe, then it makes sense to have Linux installed just for that, right? Because then you get really a big boost in speed. You can see that Blur Exterminator took almost 6 minutes on Windows, and it's only 30 seconds on Linux. It's the difference between me being able to just like sit at my computer waiting 30 seconds and then keep going, and wait for my PC, which is completely stuck on the process. I cannot do anything else at the same time, so I have to just take a walk or something, or like, you know, brain rot on my smartphone or something. So that's a big difference. But again, it's only linked to the fact that it's an AMD GPU and Linux versus Windows. And then we come to the stacking. So stacking here, I used only 16 frames because I wanted to be able to run this stacking 3 times on both Linux and Windows. It's super tiresome because each time I have to actually close PixInsight and then reopen because otherwise it remembers the cached files, that kind of stuff. So yeah, it took me a long time to get this running, and I didn't want to run it on more frames to stack. Yeah, if you're using one-shot color, even monochrome broadband in light-polluted areas, you'll typically have much more frames to stack, or if you're using a smart scope and you want to stack manually. This is also IMX571 sensor stacks, and again, only 16 frames to stack. And I would assume that the difference that we would see here would be scaled up with the number of frames. So if I have several hundred frames to even north of 1,000 frames to stack, which happens with broadband targets, I would expect to see really a massive difference in the time taken to stack. And you can see that I have all of the individual steps. We use the same settings, like the maximum quality on both Linux and Windows for the stacking, so that includes local normalization and also drizzle integration here. And you can see that the steps that had the most difference in time, really, where we lose most of the time, is local normalization, integration, and drizzle integration. The first two, I would view them as optional in a lot of conditions, so you could skip those if you don't want to feel bad about using Windows. But the latter two, I think, are pretty much essential, integration and drizzle integration, and they do account for a lot of difference between the two operating systems. And so that's another, here you can see in this 16 frames only, we saved 117 seconds. So CachyOS or Linux was almost 6 minutes. Windows was almost 8 minutes, right? So it's a large difference, and I think it can accumulate. So that's another excuse. If you want to try out Linux, again, go for something simple like Linux Mint or Kubuntu to really get to dip your toes in. But yeah, this is, I thought, very, very interesting that for stacking, it gives us a good excuse to use Linux. So what we see is that we have 25% faster for the total pipeline of stacking. So yeah, that's significant. If the stacking was going to take 10 hours on Windows, it would take 7.5 hours on Linux, right? Which means it's the difference between like clicking stack right before sleeping. I wake up, the stacking is done, and so I can do my processing before I go to work, versus clicking stack before going to bed. I wake up, nope, still need to wait a couple of hours, so I cannot do my processing before going to work, etc. Right? So that's how I see it. And yeah, so we saw big improvements in AI tools, but this is only because of the support of GPU acceleration on Linux versus Windows for recent AMD GPUs, which is what I have, and then the BS about kernel advantage. I mean, this is true, superior swap management and lower system latency overall. So yeah, Linux, indeed, as per the specification of the requirements document, does provide the optimal PixInsight processing experience on PC, right? If you're on an M1, M2, M3, M4, and 5, I think M5 exists, I don't know Mac, then you already have an amazing experience with PixInsight, so you don't have an issue. These are the results on PixInsight running on Windows versus Linux, and a bonus Graxper test as well, which also showed improvements under Linux. So yeah, maybe an additional excuse to try out Linux. Again, recommend Linux Mint or Kubuntu for beginners. And I would absolutely recommend keeping Windows and running Linux on a second disk. So have 2 disks on your computer before you're able to do all of that. Now, obviously, all of that testing and installing, reinstalling, moving OSs around, it's been an insane amount of work just to come to the same conclusion that PixInsight was already telling me. Yeah, if you want to support this kind of work, you leave a like. Thank you so much for watching till the end, because that's very important as a YouTube metric. Leave a comment. Let us know what you think of that. Do you use Linux? Do you use Mac? Do you use Windows? Are you tempted to use Linux after this video? Let me know. I'll put all of the links to like Linux Mint, Kubuntu, and instructions on how to install the GPU acceleration for AMD down in the description. Of course, if you want to support me even more at no cost to you, and you're planning on buying anything, like anything from Amazon, Agena, High Point Scientific, lttstore.com, super cool ratcheting screwdriver, or any of those, if you click one of the links that I have down in the description, it will help me out at no cost to you. And if you want to sponsor the channel directly, make this work, become one of those VIPs that actually make this channel possible, you can join my Patreon. The link is down in the description, or you can become a channel member. It's the join button next to the subscribe button. Again, you guys, thank you so much for your support. You make all of the difference. And I wouldn't be able to do this without you. With that, I hope this was interesting. I hope if you've done this kind of test before, this is roughly, you're seeing roughly the same results between Windows and Linux. Next time, I want to actually take a second look at SETI Astra Suite, because it really got much better since I last looked at it. So yeah, I'll be probably testing that and maybe having another look at Cyril as well in future videos, especially because the weather hasn't been amazing here. So yeah, looking forward to your feedback. Thank you so much for watching. Don't forget, whenever you can, to look up at the stars, and I'll see you next time.